Here's an alternate way to solve problem number 36 from the May 2022 QAS from the math portion, section 4, the calculator section. So the original method I showed basically just involves setting up an equation using the fact that when you have two chords intersecting inside a circle, the product of the segments from each of the chords will end up being equal to each other. All right, but this is an alternate method that I hadn't thought of at the time. So you can also use right triangles and the Pythagorean theorem to solve this problem as well. And the way we're going to do that is, first note that, so WZ here is equal to square root of x, and also ZY will be equal to square root of x, because they tell us in the problem that the diameter UX bisects WY, so WY, that chord, that line segment's bisected. All right, and we also know the radius of the circle is 6. So if you draw a radius here from the center at O out to Y, make that 6. You could also draw it out to W on the other side as well. It doesn't matter. And since the diameter here bisects this chord, that we also know that there is a right angle here making a right triangle. And just the last piece of information is we know that the radius is 6, so from O to X, that entire line segment is 6. They tell us from X to Z, this little part is 2. That means that this part right here has to be 4. So now we can set up an equation using the Pythagorean theorem, where we have basically 4 squared plus square root x quantity squared is equal to 6 squared. So we go ahead, square everything out. 16 plus x is just going to equal 36. X is going to equal 20. So this is the exact same answer we got, using the other method, also the correct answer. But this is just an alternate way you could solve this problem using basically right triangles and specifically the Pythagorean theorem.